KNN of the machine learning algorithm. So K nearest neighborhood and as well as the support vector machine. And there is some kind of the analogy, friends. Now, if you observe the K nearest neighborhood, only one simple thing. There are certain kind of the sets, set 1, set 2, and as well as the set 3. Assume that they are classes. And these particular classes, what they provide is some kind of the entries, maybe some kind of the data. What KNN does is it is providing us, okay, so just it is providing us a kind of distance measures. Okay, so based on those kind of the distances, we have to rate or we have to move a particular new entry into either of these particular classes. So that is the basic requirement while working with the K nearest neighborhood. So in the statistical orientation, we have seen some of the aspects, and even some of our friend also, one of our friend also has given some kind of the insights how the KNN is the principle behind the KNN usage. So just we are making use of the distance measures and all. Based on that convention, one can decide the usage of this particular thing. Now the problem here is, friends, at the moment we are talking about the KNN kind of thing. There is always we have to mention the K value, because this K value is nothing but how many with how many values I need to compare. Because if I am giving very low value, if I am giving very high value, both are troublesome. If I am giving very low value, suppose if I am comparing with only one, there is meaningless. Maybe I will be getting some biased data or some kind of the biased output. Whereas if your K value is very large, then obviously we are comparing many things, because every time what we are doing, just we are comparing, and based on this particular comparison, the distance would be there, and whichever the less distance we are having, so that we can conclude the appropriate new entry into the specific class. There, if you remember, friends, long back we have seen one example actually, like some kind of the drink, and we want to classify that particular drink into some specific model. Okay, maybe the drink is belongs to hard drink or cool drink or fuzzy. Okay, so like that, different categories are there, each and every aspects. Okay, if you observe, all those kind of the things can be observed. So this is one thing related to the KNN. Now, before starting exactly the implementation, again, because 3 or 4 days we left with the sessions, um, so that let us have a, specification of this Python template. So how we are moving while dealing with the coding kind of the aspects. Can someone help me, friends? What is the very first step we need to perform? Maybe all are
Import the packages.
Import the packages. Very good. Import the libraries or packages. Now tell me, friends, which are all the common libraries we need, especially in the NumPy, Pandas kind of the way we have seen. But whereas now we are using some sklearn kind of the aspects. So here, as a kind of the specification, you can import some kind of NumPy as NP, and you can import Pandas as PD. Because the reason behind this is, guys, your machine learning and data science is not only dealing with application of the models or algorithms. It also performing some exploratory data analysis, and it is providing some visualization, and you can perform some kind of we have done some aspects like scaling, and thereafter we have normalized our data, and sometimes we have converted the data into the one hot encoding, label encoding, dummy encoding, like that. There are certain aspects. So according to the requirement, we need not perform all these things all the times, but whereas whenever there is a requirement, then we have to bank on these kind of the specifications. So so as to make use of these kind of the methods, definitely I should dependent on this NumPy, Pandas, Matplotlib, Cburn, all those kind of the things. Okay, so sometimes we need to import uh, Matplotlib dot pyplot as PLT, and Cburn also will use, guys. Import Cburn as SNS. Okay, these are all the most commonly used, and the terminology should be very familiar. Second important thing, friends, okay, we are having the corresponding libraries. What is the immediate thing we need to do?
We have to load the data.
Loading the data. Very good. Loading the data. So this particular load data generally provides the pandas way pd.load data set, and correspondingly the case studies we have seen. In case of the regression, which case study we have seen, friends? Just to try to recollect. Simple regression, multiple linear regression we have seen. In both the cases, one common scenario we have taken. Sales team, and as well as the some kind of the marketing, how these kind of the marketings are really helping. Okay, all those things we have seen. Those things. So loading of the data, generally with the help of this pandas, you can load the data. Now, once the data is loaded, immediately there are some kind of the options available, guys. So which are all those options? In general, what we'll do?
After we separate the dependent and independent variable. Okay.
Before that, as a general, as a typical machine learning engineer or data scientist, you need to think through what exactly this data is basically. So because I need to have the standpoint of understanding, like, okay, these are all the features I am having, and what exactly the appropriate data set is trying to say. These are all very important considerations, friends. Okay, the information and as well as the description about the data. Can someone help me? What is the difference between describe and info?
Info it gives the columns.
Very good. Gives the
Columns
column information, and how many number of rows are there?
Non-null.
Any non-nulls or nulls are there? This much we can have. But a description, friends, what it gives actually?
Statistical information.
Excellent. The statistical info. Okay, this particular statistical info, guys. So starting from the minimum, maximum, count. Okay, all these kind of the aspects we generally make use related to the statistical info. And once this understanding about the data is over, the next important aspect, friend, we have to segregate. Okay, the X and as well as the Y. Okay, so this is the basic step where you can bank on while making use of or before applying any kind of the algorithm. Now, what do you mean by this X value, friends? Basically,
independent.
Yeah, these things are nothing but the independent variable, and this is nothing but the dependent. Dependent. And by the way, if you are referencing this independent, this is also known as features. This is also known as label. Okay, label. So this is how you can refer, and there we have seen some kind of the strategies. Sometimes we are making use of that LOC, ILOC. Sometimes you can mention with the help of subscript we have separated, or else sometimes recently what we are doing is we are simply mentioning some of the columns and by dropping some other columns, so that we can follow various ways. Okay, so as to separate X value and as well as the Y value. Once this particular thing is over, friends, probably what is the next step? Some kind of the pre-processing. If you want to apply
missing value or
missing values or any kind of thing, missing value imputation, and some kind of the encoding. And then friends, any other feature scaling? Okay, so all these are the conventions related to the data pre-processing. Next important thing is, okay, we are happy with the data, and we have seen some kind of the XY separation and pre-processing also. What is the next immediate step?
you have to do the train and test.
Very good. Train,
Splitting
test, split. Train, test, split. Now, friends, here the point is in the train, test, split. Generally, how many? Which are all the outcomes, friends?
X train, X test, Y train, Y test.
Very good. Y train and Y test. And these things are generated by what is the thing we have to give as a part of these? Suppose if I am giving train, test, split, which are all the parameters I have to give? First thing is, however, X value. Second thing is Y value. Now, if I am giving the test sample or test size, if I am giving, this is 0.7 or 0.3 or 0.25 like that. And random sample, if you want to give random state, if you want to give, you can. Otherwise, you can give as optional. Okay, that strategy is there. Now, once we have done with the splitting, what is the next step, friends? Here, what is the next step? Train test split is over. Now we got X train, X test, Y train, Y test. What is the next step? Algorithm selection, fitting the model. So that means this particular fit model, which are all the parameters to fit the model, guys?
X train and
Y
train. Okay, X train, Y train. And before fitting the model, you need to select the algo. That's what I have clearly mentioned, algorithm selection. And here probably we are having the model, our model we are fitting. And thereafter, guys, what is the next step? Predictions. For these predictions, what exactly we are doing here? Y pred is equal to predict of. What is the parameter here? We need to send
X test.
X test or Y test? Okay, Y test we never use Y test. Okay, in the prediction. Once we got this particular thing, next is, friends, measures or metrics. What we are doing here, friends, in the metrics or measures? We are going to establish a kind of the relativity between Y test and as well as the Y pred. Okay, and this is your inference actually. Finally, the 10th step is the inference, okay, based on the observation. Can someone help me in case of the classification? Because we are now in this session, we are discussing KNN and as well as the SVM kind of the implementations. In case of the classification, which are all the most popular metrics or measures?
Confusion matrix.
Confusion matrix.
AUC ROC.
AUC ROC curve.
Classification report.
Classification report. Classification report. These are all the important aspects where you can refer the specification of classification. And by the way, before launching the things, just we'll see the regression aspects, regression metrics. Already we have seen, which are all the things, friends? Root mean square error, R square, adjusted R square. Like that, we are having some kind of the matrix. So now, if you are referencing the confusion matrix, so basically this confusion matrix provides, we're having some true positives, true negatives, false positive, false negative kind of thing. So based on the convention, okay, you can make use of, okay, the finding out of precision, recall, sensitivity, okay, all these kind of the things can be observed. Now, Suresh, are you ready with the confusion matrix discussion?
Today, no voice.
Okay, okay, very good.
I'm sorry. I'm very
It's okay.
unsensitive.
No problem. Yeah. No problem. Okay, so let me give some kind of the insights of this confusion matrix, friends, because that is mandatory. Nothing is there other than that confusion matrix in the KNN Erlang. So because the first time what we are doing is we are making use of that confusion matrix, and moreover, if you are referencing the whatever the classification kind of the things in our all random forest, support vector machine, decision trees, okay, we are going to make use of this particular confusion matrix. So let me paste some kind of the diagram so that you can easily reconnect. Okay, this I have used in the session, actually in the explanation of the confusion matrix. You can have a look on this. So just observe here, we're having true negatives in this particular slot. Okay, so that means our prediction is no, actual is also no. This is required, friends. Okay, true negative value. Let us compare. Once the code we are using, just we are generating the kind of the aspects. Similarly, guys, here we are predicting some kind of the S here, but actual no. So whether this is required or not. False positive. This should be low. Required or not means that should be low, because we have predicted as yes, but actually that is no. Now false negative in the sense, guys, we are predicted as no. Just to see, think through like this. This is one column. Just we are working on this column related to this one we are working. So now at the moment I am talking about this notation, we predicted as no, but actually that is yes. This is also not required. Now the true positives we predicted as yes, and our requirement is also, of course, the actual data is also yes. This is required. So now you observe the point in the generation of the confusion matrix. You have to focus on these two values. If these two values are more and these values are less, then your model is fairly doing well, guys. Okay, so observe that in this particular thing, first, okay, if I'm giving names as 1, 2, 3, 4 kind of thing, your first quadrant and fourth quadrant must be high. 1, 4 quadrants must be high. Your second and third quadrant must be low. Okay, so based on that particular convention, you can observe. Now, apart from these, friends, we are having some other calculations actually, because we are having the precision, recall, all those kind of the things. Let me pull that also. Somewhere I have registered those things. Just hold on, guys.
If you want, I can put my PPT.
Yeah, got it, guys. Thank you for that. And yeah, support, confidence, lift, yeah, true positive, true negative, correct, accuracy. Got it, Suresh. If you want also, you can put so that our guys can use, no? You can share in the chat, no problem.
Okay, I'll put in the chat.
Yeah, because after this, let me see how you have worked, and because I am eagerly waiting.
Common chat, this one. Are you
common
in the common chat?
Common chat you can put everyone you can put.
The WhatsApp chat, I'll put it.
Or else you do whatever the means.
You can put it in this chat.
In
Okay,
this chart
okay,
also,
I'll put
I
this.
mean to say that one only actually.
Okay, okay, I'll put.
Yeah. No problem, guys. Here, let me explain in this way. Before our friend is, however, he is putting in the chart a nice PPT. We are not having the habit of dealing with the PPTs because that is all high-end guys. We are only learners now. That's what we are standing in OneNote and all the other practically followed approach. Okay, like guys, here there are certain aspects like accuracy, misclassification rate, error, true positive rate, and false positive rate, specificity. Like that, some other things also there where you can apply. Okay, where you can observe some kind of the scores or some kind of the the confusion matrix is not going to give directly the output of the precision, recall, all these accuracy kind of the scores. But apart from that, what it specifies is it is hardly giving true negative, false positive, false negative, true positive, those kind of thing. But however, what we are doing is accuracy can be defined as overall how often is the classifier collect. Okay, what do you mean by classifier here, guys? What do you mean by classifier here, by the way?
The confusion matrix. How it is classifying the.
Just to re-examine.
Prediction.
How our algorithm.
That's it. That is mean the algorithm only, na? Classifier means your model, guys. Just to see, be cautious. Okay, so maybe that is KNN, maybe that is SVM, that might be decision tree or random forest. Classifier means what? Which is used to classify our data set. So based on our data set, just this particular algorithm we are using to create the model. Classifier specifies that which algorithm you are using, and your model becomes the classifier, friends. Can someone help me? What is the difference between model and algorithm? Model and algorithm, guys.
Algorithm is a mathematical equation.
Yeah, here observe, guys. Here algorithm is something like which is predefined. Okay, we have I defined any algorithm, or have I we have never populated any algorithm. We are using the algorithm so as to generate our model. So maybe that is the simple linear, multiple linear regression, whatever. What we are doing is we are trying to make use of the kind of the algorithm. Okay, based on that we are fine tuning our approach. That is nothing but the model. So what we are doing is making use of the algorithm. We are converting that algorithm into the model by providing the input data and by observing the kind of the measures, all those kind of the aspects. So if you are referencing the accuracy means what? Suppose if I am asking about a particular person, okay, whether he is accurate or not. That means whether he is how many times he has reached to his targets, whether he could able to get the variable pay or not. Okay, and that is a big deal, na? While reaching to our year appraisal report or something like that, there are certain aspects. So that accuracy always a standpoint where you can where the people especially corporate guys are looking these kind of the accuracy. Okay, but they won't be accurate at any point of time. Okay, so we should be accurate, however. So now the point, friends, here, how often the classifier is correct? That means your model is correct. Now, out of these two, friends, which are very much high, one should be high and four must be high. Na? If these two are high, then obviously I can say my model is good. Agreed? If these two are, that means whenever there is a no, if my model is also observing no. Whenever there is a S, my model is also observing S. In those particular cases only, I can say my accuracy is high. So what they are saying is out of total entries, whatever the number of entries we are having, and add true negative and true positive. In this case, friends, we are having 50 true negatives, 100 true positives, and by 165 because total samples we are having 165. If you could able to compute, okay, around 90% accuracy, we got 90.91 something. Okay, if you convert into the percentage, we'll be getting 90%. Okay, so that means the accuracy is banking on true negative and as well as the true positive ratio of this total samples. Now, what do you mean by misclassification, friends? From these from this confusion matrix diagram, how do I refer my misclassification? Which are all the parameters I need to consider so as to come up with the misclassification rate? Oh, a lot of changes happened. And in the earlier sessions, I used to hear many voices and more competent. Oh, with 4 days of the gap, see how the collections dropped. Huh? Okay, maybe Suresh voice is not good, Venkat health is not good, and
I'm good.
my mood is not good. Okay, many things were there. Lakshmi, however, she is active. Our Akash is, I cannot ask Akash because always he is a newbie to me. So Neelima, Ramakash again. So Ramakash, after a long time I'm seeing. How are you?
Yeah, I'm fine.
Okay, Akash, have you going through the recordings and all? Hope you are.
Yeah, I am, but even today also I'm likely to join these
Yeah,
sessions.
why, Akash? Why nowadays I'm not seeing you any issue or?
Because I'm busy in my college work actually.
Oh, is it? Is it?
Mid exams are going on. Within 10 days, I'm having sem
Okay.
exams.
Have you prepared?
Yeah, I'm preparing. That's why I'm not able to join.
No, it's okay. Just to go through
Yeah.
the recordings, and
Yeah,
whenever
yeah.
you are having doubts, you post in the corresponding channel so that I'll
Okay.
respond back. No problem. Okay.
Okay.
Take care,
Okay.
Akash. All the best. Huh?
Okay.
Right. Okay. Coming to this other option, friends. Actually, if I'm making use of my nose, I mean this whatever the misclassification we're having. So this misclassification is nothing but how many times our model failed to properly observe the things. So that if you refer the second aspect, friends, the parameters false positive and as well as the false negative, out of these cases, out of these many number of cases, how many times we have failed, no matter whether that is yes we have predicted as no or no we have predicted as yes, both are wrong only, no? Both are wrong only. So for that particular thing, we are having the error rate. Okay, error rate, obviously we are having very less error rate, 0.0909. Okay, so only 9% of the cases we are having some kind of the errors. Now, what do you mean by error, friends? Which is simply 1 minus accuracy, because I got some accuracy. If I am removing the accuracy from 1 minus, that we are also getting error. Something like we have seen in the probability also, na guys. Can you relate that one? In case of the probability also, we have seen some p comma q values where q equal to 1 minus p. Something like we are telling what is this p actually? Probability of happening and probability of not happening. Okay, so and one more thing, friends, here true positive rate. Okay, so what do you mean by true positive rate is when it is actually s. That means actually s means, friends, our not from our algorithm, from the data. Okay, from the data, how many times we are having yes, how often does it predicted yes by our algorithm? Okay, just to observe this. How can I refer this point in terms of y? In terms of y, if I want to manipulate this one, y test or y predict this one? Oh, guys, come on.
No, it is Y test.
Y
When it is
test.
yes.
Yeah, this is However, simply it is there now. Why? Pred. Now what we are doing, friends, we are comparing between these two in such a way that whenever our y test is yes, how many times our y predict is also test. Where do we get the data, friends? Actually, we need to predict it as yes. Okay, and our actual also yes. This is the case now. True, positive. That is what we are using. Okay, so simply you can easily connect the dot, friends, from the confusion matrix. You can easily specify the true positive rate is known as the sensitivity or recall, friends. Okay, if someone asks you, so just you can find out the accuracy, or else you can find out the recall. Okay, recall is nothing but how many yes actually are there, and how many times our prediction, I mean our model is also finding out the true. So that what we're doing here, true positive rate. Okay, generally what we're doing is true positive by actual s. So from this particular equation we'll be getting that. So our true positive, how many are true positive? 100 by what we're saying here, how many yes are there really. Okay, so this particular thing, how many yes are there, friends? 105. So just what we're doing, 100 by 105, and 95 times, 95% of the times our model could able to track the actual S from the appropriate data set. Now, oppositely, we are having the false positive rate. That means when it is actually no, how often we are predicted as yes. So obviously the thing is like this, friends. False positive rate, specifically you can observe that false positive rate, okay, by actual number. So actual no, I mean, so the false positive rate is 10 and actual no's are 60. So that obviously you can see, so these many times, so 16% is you can observe the false positive rate here, the false positive. Okay, how many times we're having, so actual no, and as well as these kind of the things we have observed. And thereafter, okay, specificity. What do you mean by specificity? Is it is very similar to the recall, very similar to the sensitivity. When it is no, and how many times our model is also predicted no. So true negatives by actual no, we are getting 83%. So specificity can be known as 1 minus false positive rate. Already, if you are having false positive rate in your hand, you can make use of the specificity. What do you mean by prevalence, friends? Prevalence. Okay, so out of total conditions, how many yes we are having? Okay, this is not that much useful, guys, because according to the data set, if that is also not having more yes, then we can, if you are banking on these kind of thing, it won't give any advantage to us. Okay, but basically we in general, as a data scientist and in the team also, we generally use the accuracy score and as well as the true positive. These two are very much helpful so as to make use of the convention, like, you know, so where I can represent the kind of the data items, and with the help of this confusion matrix and these kind of the measures, one can easily go through, okay, how our model is really doing. Now surprisingly, one more point is to understand these kind of things we are struggling like anything, but whereas in case of our algorithm, it is not that much difficult, guys. Okay, so that what we are doing is, just let me go through our whatever, what is that, OneNote, not OneNote. 1 minute, guys, just let me open that Jupyter notebook which already I have created for us. So this is case study. Let me share that so that you can observe. Yeah, so we have seen these thing in the earlier session, friends, but we have not discussed each and every line of the code. So what is the scenario, friends? Can someone help me to connect the what exactly we are trying there? Data set also we have seen. There is a company where we are getting the some kind of the data, and they want to hide their features. That's what I told. Maybe if I'm not having complete understanding of what exactly the feature, based on the numbers generated by our model, based on the metrics, we should able to infer the data. So that is also one of the important things. So we are having some classified data, okay, from a company, and they are not ready to give the, or else not not ready to reveal the appropriate information related to that particular data items. Okay, now what we are doing is just we are applying the KNN. Okay, so as usual, the first part is related to the libraries import. What is the use of these pandas, friends? Basically, pandas is used to read the data, especially in this particular case. And whenever you want to perform some kind of describe option or info, okay, on top of that you can refer. And what do you mean by data frame? Because some of the aspects commonly they ask in interviews, guys, because we are about to complete the algorithms, and you should be able to think through what exactly the data frame and what do you mean by series. All these are very much important. Okay, so can someone help me? What do you mean by data frame in case of the pandas discussion? Data frame, series, array, list, tuple, set, whichever, what is the other thing? Dictionary. Guys, whether you are revising or not, or else I have to put some kind of the quiz or something like in session. I thought of putting that, but we have we are now in the 40th session, of course. But I'll do one thing tomorrow, just to have a just to prepare all these things. Okay, data frame, series, array, list, tuple, set, dictionary. And apart from these kind of the things, I am asking you guys to prepare what exactly the NumPy usage, and thereafter the pandas usage, and then Matplotlib, and then some kind of cburn. So from the company point of view, also in the interviews, friends, you need not by heart all whatever the methods we are having in the entire libraries. It is not practically possible also. Generally, tons of the methods would be there in these libraries. Okay, no one, even in the machine learning landscape, or in case of data scientist landscape, no one are using all these kind of the tons of members or functions. But so commonly used things are there. Na? If I'm talking about the NumPy, can someone help me? Which are all the constructs we have studied there? NumPy. Basically, what do you mean by new? This is a numerical Python. NumPy means numerical Python, nothing else. So all the numerals means definitely I should bank on the arrays. And within this particular arrays, we have seen a range function, some kind of the range function, all these kind of the conventions we have seen. And so basically the numerical kind of the constructs we can observe. Whereas if I'm talking about the pandas, which are all the constructs we have seen, friends, basically pandas are built on top of the NumPy only. And this particular pandas helps us to simplify the things. Okay, because in case of the NumPy, everything is looking in terms of the numericals. But whereas if I want to perform some kind of the tabular data, and on top of that, if I want to apply some kind of the info, and as well as some kind of the describe of the data, so in that case we are having that series and as well as the data frame. Okay, these things are belongs to the pandas. What about the Matplotlib and cburn?
They're used for
Visualization. Okay, na visualization. So that I am not explicitly mentioning the functions, friend, because it is all your wish. Maybe Venkat is interested in heat map. Maybe Suresh is interested in bar chart. Maybe Lakshmi is interested in some kind of categorical plot. So it all depends. Histograms are there and pair plots are there. Like that, we're having plenty of plots, friends. Okay, so but no one are going to expect to reveal all the things. Maybe they can ask like this: which are all the plots you have used in your project, or else which are all the most commonly used plot in your project. So at least you need to give some one or two. Okay, so for those kind of the convention, friends, these are most important. Algorithm wise, nothing is there now. Suppose if they are asking about KNN, then obviously we have to tell distance based measure, which is a lazy learning and which is not having any kind of the learning, like that you can say. Whereas SVM based on the support vector machines, so to maximize the corresponding distance, and moreover it is related to the kernel trick, like that you can easily tell. Okay, so but the majority of 70 to 80% of the questions are revolving around these libraries and your stat models and all these kind of the aspects which we have seen so far, those things. And algorithm wise you can easily crack, friends, like KNN. If they are asking SVM or not much, they cannot grill your potentiality on the lines of these algorithms. That's what I am saying. Okay, so be cautious and be mindful, because don't take chance, friend, because the revision is most important actually. So the power of revision, power of preparation cannot be replaced with anything. Of course, hard work is top, and on top of that, just you have to be cautious to learn the things and prepare the aspects. Okay, that is always I wish from you. So whatever the algorithms I'm having, all these kind of the algorithms we have, I mean libraries we have imported. So now what is this for, friends? Percentage Matplotlib inline. We have seen somewhere this thing. So this algorithm may be executed throughout in many kind of the machines. Okay, so in that particular case, suppose if that particular algorithm should not be affected by the current machine's performance or efficiency. So just whatever the algorithm we are using, just if you are if you want to specify the inline, so that means every machine is having some kind of graphics cards and all. So efficient and effective usage of those kind of the graphics card and all can be done with the specification of this line. Even though if you're not giving also, no problem, friend, but the general convention is maybe if I am running my code in somewhere, maybe in AWS cluster or in some other deploy mode, so it is always helpful, okay, to have these kind of the inline method of executing the Matplotlib. Now once this particular thing is over, just you can load the data, okay, with what is the outcome of the read underscore CSV, friends, in the pandas? Data frame. Always, you know, that is what I asked, what is a data frame and how we are making use of the data frame and all. Now from this column equal to 0, what it is specifying is the first column as the index column, because we want to maintain this 0, 1, 2, 3, 4 is a serial number kind of thing. We don't want to put that as a actual data, because if I am putting that as actual data, it is coming into X values, but my X values start from this subscript only. Okay, so that is what we are putting this particular index column as 0. And head, if I am what is this for? Head means only top 5 rows. If I want to get, I want to get the first 5 rows of the corresponding data. If I want to get the last 5 rows, what is the command, friends? What is the function? Tail. Okay.
Okay.
Now one more thing, if you remember, in case of the KNN, what is the main functionality of the KNN, friends?
Measure the distance, so we have to
measure the
standardize
distance. Okay, to measure the distance. Why we need to standardize, guys? Why we need to standardize? Only simple thing.
some of those variables as the independent variables as important or on priority, and so we get wrong
correct
analysis.
So based on the scale, there is a chance of the algorithm can treat them as high. Okay, so Suresh is on video mode. Okay, I can see Suresh very well. Okay. No problem. It's okay. So, and one more important thing, this kind of standardization really helps us to perform. Okay, like all the variables, all the values, whichever I am having, into a consolidated kind of thing, maybe age, salary, all this kind of thing, I can bring them into a common scale. Now, what is the technical thing supported by Python to do that? One is the pre-processing, and under the pre-processing we are having the standard scaler. Friends, you have you remembered this thing? We have done some 2 or 3 use cases before the start of the algorithms also. In the first use case, we have taken some kind of the missing value imputation, and thereafter in the second one we have come across with the encoding techniques like one hot encoding and label encoding. In the third aspect, we have come across with the feature scaling. So those 3 aspects, and then we started our discussion of the simple linear regression, multilinear regression, and now we are dealing with the KNN. So these pre-processing techniques are common for every algorithm, friends. Don't feel that only your algorithm is changing. By this time you would have realized that point. Only the algorithm is changing. Remaining templates are same, whatever the paths we are following. So we are taking that particular scalar, and just what we are doing is with the help of this standard scalar. What do you mean by target class, friends? Here, what is the target class? By basically target class is nothing but label y, label or y. So now what we are doing is here, just after taking this particular standard scalar, and we are fitting that particular model or whatever the data item we are having, except this particular target class. We are excluding the target class from the standardization. Can someone help me why it is so?
Already in the standard scale.
Already in the outcome, that is 10. Then what we need to do again on the target class? So that's what we are dropping that. And what do you mean by this access equal to 1? Oh, friends, you need much preparation, guys. Okay, that access equal to 1 means we are affecting the things to all the rows. That's all. Okay, so suppose if I'm having 1 lakh rows, for all those 1 lakh rows, I want to apply this kind of the transformation. Okay, across all the rows, I want to apply this kind of the convention. Now, which are all the features? Okay, this thing is done, the appropriate scaling and all. Now, scaled features we are having after getting this particular target class dropped from the appropriate data frame. Sorry, and now features we are selecting, friends. How we are selecting features? From the data frame. Okay, pd.data frame of scaled features. Now, whatever the scaled features we are having, now columns, if I am saying like this, friends, what is the outcome? df dot columns of colon and up to -1. That colon refers all the columns except the
Minus last column.
last column. -1 means last one, friends. Hope you are all knowing that. Now, once that particular scaling is over, just we are printing the data. Now you can see the difference between earlier data and as well as the now current data. Okay, so that all are in the common scale. All are in minus up to some kind of the extent you can see the observation. From this particular point, what is the next step, friends? You need to explain this. What is the next step? Train test split. Basically, what this train test split does? It split the appropriate x and y value into x train, x test, y train, and y test. Reason behind that is we are going to use this x train and y train for the sake of the fitting the model, and our y test. Okay, we are keeping aside, but our x test we are using for prediction. For the prediction. Now, for that particular purpose, friends, what we are doing, train test split. Okay, which is available in the what do you mean by this sklearn? Oh, scikit-learn. Okay, from that we are having the model selection. What is the other model we are having in the sklearn? Suresh, Venkat, your favorite? cross validation. Okay, k-fold cross validation and all. Okay, so you can make use of that cross validation, but commonly nowadays what we are doing, friends, we are not emphasizing that particular k-fold cross validation or those kind of thing. With the model selection itself, they have optimized the performance of this thing, so that we are directly making use of the model selection and we are applying the train test split. Now, if you refer this point, friends, actually, what we are doing is just we are X value here is having in the scaled features, just the names are changed, friend, that's all. And your Y value is, however, the DF of label or target class. What about this test size, friends? We are taking 30% of our data is for the testing. And that means, what is the train size?
70%.
70%. This is a kind of 70% training data. If I'm taking, test size should be 30. If I'm taking 0.25, obviously that is affected to training as 75. Now, friends, see here, maybe you would have seen the kind of simple linear regression so as to fit into our data set. Now, for the sake of this KNN kind of the aspects, what we're doing is from sklearn, if you remember, in case of the linear regression, how we have imported the model, friends? From sklearn dot linear models import linear regression. But here what we are doing is, so as to get my k neighbors classifier, I can make use of the sklearn just with the help of the neighbors. So from sklearn dot neighbors, from that we are importing our k neighbors classifier. Now, one of the important point here, friends, how many neighbors I need to take? Okay, because what do you mean by neighbor, friends? Basically, let me share this thing once more. And 1 minute, guys, so that you can empower you with the understanding of the KNN. I'm trying to give that values. Actually, I have shared this thing long back with you, a note on algorithm kind of document. So before coming to the tomorrow session, definitely you should go through that document, and then you can come up with your analogy, like what I'm taking here. Let me take. Can anything is coming into your mind, guys?
Yeah,
So,
the number of groups we have to.
number of no comparisons, Venkat, actually. So maybe I'm having some groups, neighbors. How many neighbors we are comparing? Okay, so in that particular case, just we are trying to connect our understanding with the coding purpose. If I am taking this 5, okay, that means I'm comparing my whatever the data I'm having as a new kind of the data. So just we are comparing with all these 5 neighbors. So I'm putting that neighbors as 5. So basically what I'm doing here is KNN. This is the reference, and I'm making use of the K neighbors classifier. And within that, I have to send one parameter like how many neighbors we are going to compare. Okay, 5 neighbors, because I want to find out the distance. Now, what is the typical process, friends? Once the reference has been generated, KNN.fit model, and of course, parameters are X train and as well as the Y train. Nothing change. And in case of the prediction, what should I send as an argument for the prediction? X test. So finally, now my prediction is recording all these kind of the X test value related to the appropriate predictions. Now, according to the specification of this matrix, which are all the metrics I can make use, friends, in case of KNN or any other classification technique. So as usual, we are having the sklearn dot matrix. We are importing the classification report and as well as the confusion matrix. Classification report and as well as the confusion matrix, these things. Now, how do I generate the confusion matrix, friends, between Y test and as well as the Y prediction? So just now I am using the prediction only, and along with the Y test. Y test means actual values, and our predictions are the value generated by our model. Now can you comment on this thing, friends? What exactly we are having here? Can someone help me to understand what exactly the 138, 11, 10 and 141? 138 is
True positive.
True positive or true negative?
True negative, and 141 is true positive.
True positive. And what is that 11 and 10? Obviously, false positive and as well as the false negative kind of things. Okay. Now, by seeing this particular thing at an outset, just you can refer these values are high. That means whether our model is really doing well or not. Of course, no? Of course, it is doing well. So 138, 11 and 10 and 141. And now, okay, with this, I am not satisfied. What I am doing is, even you need not compute your precision, recall, support, all the things, friends. There is one more metric we have used actually, along with the confusion matrix, we have used the classification report. Now, suppose if I am not using confusion matrix, what is the problem, friends, here? If I'm using only the classification report without the confusion matrix, then what could be the confusion here? Or what could be the disconnect here? Can someone comment on that? Again, a big silence like Ram Gopal Varma movie.
Exact precisions cannot be seen in confusion.
That's it.
matrix.
You cannot, one thing, always we are having the benefit of doubt. Somehow you need to have some kind of the understanding of the formulas, friends. Okay, that's how before even without any precision or recall or true positivity or sensitivity rate, you can enjoy the usage of this confusion matrix. But the debate here is, as a data scientist, you have to catch hold of, okay, you should be in a position to catch hold of, can I compute myself the precision value or recall, so that if you are having the confusion matrix, you can double check, because in front of you we are having true negative, false positive, false negative and true positive, all these things we are having, and again we are having the formulas also for the precision recall. So directly you can compute yourself, and you can you can match those kind of the aspects with the classification report. That is evidential only, na? Basically this is the evidence, because this is generated from our data set only. Of course, this classification report also generated from our data set only, but the point is you can manually compute the things, and you can check with the precision and recall. Okay, but that requirement may not be needed whenever there is a kind of discussion. Then only we can go and manage these kind of the things. Okay, now just observe here, friends, we are having the precision 93 and where accuracy is also 93%, fairly good amount of thing. But now there is a standpoint, actually you should have some doubt here. Suppose in this case, what is the parameter, friends? Which one can I change from the entire lines of these 4 lines, 1, 2, 3 and 4 lines I'm having? Out of these 4 lines, where do I apply some kind of the change, or where can I modify my appropriate parameter? Can I change in the K-neighbor classifier?
No, the value of the second one.
This one only, na? How many neighbors I'm having? Now you see, friend, because I cannot conclude this 5 is correct, because this is only the parameter I am having in my hand. Okay. Now what I'm doing is, if you observe, this particular K neighbors equal to 1 I am giving. That means, so just at this moment of time, rather than making use of K neighbors as 5, okay, just what I am taking, K neighbors as 1 I am taking, and remaining thing all I am generating. Like I am fitting my model, I am predicting the things, generation of the confusion matrix, and as well as the classification report. Now with K value as 5, I got these values. Let me try to copy the things if I could, so that we can easily compare the aspects. 1 minute, guys. Okay, yeah, I can. And thereafter what I can do is here with K value 1, I can able to observe this particular value. So side by side we'll compare. Now let me share the OneNote with you guys. Okay, observe, friends, here. This is what is our K value here, friends? My k value is equal to 5 here. My k value is equal to 1 here. Now you tell me what is the distinction you observed here? Because from the k value 5, I can able to see my 138 and as well as 141. Whereas if I'm getting k equal to 1, this is slightly reduced. This is also reduced, guys.
It should be more. No?
It should be more, na? So that means obviously my k5 is doing really good compared with the k equal to 1. Likewise, if I am talking about the negative values, in my k equal to 5, the negative values are spread over like this, 12 and 15. Whereas in my k equal to 1 kind of thing, they have 12 remains same, friends, but sorry, for this k equal to 5, we got 11, and as well as this is 10, friends, 11 and 10. But whereas in k equal to 1, I am getting this 12 and as well as the 15. Now see here, these values should be less, but in case of the k equal to 1, I got more values. Then what is your conclusion from this point? Okay, in a high level view, if I am making use of k equal to 5, my true positive, true negative are more, and false positive, false negative are less. Okay, by comparing these two. That is not okay, friends. Along with that, we have to compare the other kind of things. Okay, just have a look on the precision with k equal to 5. Okay, just I want to get the precision value related to my k value as 5. So if I am talking about the precision, I am having how much precision, friends? We are having 93% of the precision, and accuracy is also 93. Whereas if I am taking my k equal to 1, what is the precision value here? 90 and as well as the 91, which is less than k equal to 5 or not. Okay, so obviously my precision value and accuracy is not competing with my k equal to 5 value. Now in the other way, even I can try more values also. Na? So what I am doing is here, now this time I am putting k value as 23. Okay, remaining all same, friends, fitting a model, predicting your model, confusion matrix, classification report, all are same. But this time what I am doing is just let me take this thing, confusion matrix, into our discussion. And now let me paste this particular thing. You can able to see your k equal to 3, whether it is doing really great with k equal to 5. Now I got this k equal to 5, however. So let me compare these two things also. I am pasting k equal to 5 here. Now observe here, friends, what is the point you are making out here? Whether can I go with k equal to 23 or k equal to 5? Just to have a look on this. What is your analogy?
Only a change in the true positive. Not much.
Not much. Okay. One change is here I am having 143 and here I am having 141. Okay, that is one thing. Any other, friends? If you see here, we are having the negatives as 10 here, but here only having negatives as 2. Our required things are greater here, trues are more. This is false in both the cases. Okay, that means I can able to see 143 trues if I am using k equal to 23, whereas I am using only 141 if my k equal to 5. Okay, so now this is not enough. We need to see the precision and recall also. Now if any difference is there. Now you see, friends, here in the earlier case I could able to see 90 and as well as the 91 with 1, whereas 93 in case of the k equal to 5. But whereas if you see 95 and 94 kind of the accuracy. So this is how you need to analyze your neighbor's specification, and based on that particular convention, one can easily observe where do I get the most more number of the positives and less number of the negatives. So this is how we are going to relate, okay, the understanding of stats behind the KNN and the connectivity of the confusion matrix. And once that particular confusion matrix has been generated, you can map that particular confusion matrix entries with the help of the classification reports like precision, recall, and all the other kind of the things. And I am strongly recommend you guys, you can work out what do you mean by F1 score and support, because Suresh would have done some kind of the work. Maybe I'm expecting you guys to have. And however, let me take this chance of giving the task to you, because I'm worrying about your revision process. Okay, completely tomorrow I'm going to dedicate to again the points which I have mentioned. Along with that, some other tasks, like you need to come up with what do you mean by support and F1 score. Precision recall already from the confusion matrix you can talk. And one more thing, friends. Okay, first let us clear these kind of the points, because without having the understanding of course, you know, but after 4 or 5 sessions, we are not having any communication with these kind of aspects, so that maybe a little bit revision is required. So definitely once you go through these kind of the revisions, you can have the convention of making the things simple. Now let me introduce one more aspect, because our way of dealing the algorithms is first we'll go through the entire case study, and then we'll in the next day just will each and every aspect we are going to talk. Now in that regards, what do you mean by this support vector machine? Which are all the important aspects we need to observe as a part of our support vector machine? Can someone talks about that thing, friends?
Support vector machine is a supervised learning, which has which comes under the classification type.
Yeah.
And it is more based on the margin between
Margins. Okay. What do you how can you rate these things, friends? What do you mean by these points actually? Lakshmi, Suresh, Nilima. Support vectors, na? These are all nothing but the support vectors. Based on these support vectors only, the margin length can be decided, if you see. Okay, so these kind of the points are acting like as a margins, and within the hyperplane and all.
The distance you are calculating, the distance.
That's it. These are nothing but the support vector. Distance where, because the
based on those one will be.
That's it. Whatever the distance we are compute. Again, one more thing, friend. There we have seen one analogy. KNN
Actually,
plus,
shortest one.
KNN plus linear regression is equal to SVM, guys. Very simple analogy. Because we are computing the distance and we are getting the best fit. Best fit, where do we observe? In the regression. So your KNN and linear combination is nothing but your support vector machine. One more point, if you see, what is the important thing, friends? Maybe very important question in the interviews is what is the significance, or what is the speciality of the SVM out of all the algorithms? Can someone quote that point, friends? Many a times we have seen. Kernel trick. What do you mean by kernel trick? Let me put the diagram also. Kernel trick. Where is that? Yeah. 1 minute, guys. Hope you guys remember this diagram. What is the difference between this first diagram and as well as the second one? Just to think through. We have spent some quite amount of the time that whenever we have dealt with this discussion. No idea? See the
Yeah.
point. Venkat, go ahead.
And longitude, because now it's difficult to establish the margin. So we took we are taking the different parameter where we can establish the we can differentiate between the.
How can we can able to separate now? We can able to classify them now. That means you observe here, guys. If you see our data set and how it is spread, it is non-linear model actually. If you see, the data is spread like anything, like all the points are spread over and they are not in a proper position to understand. Okay, but whereas with the help of the kernel trick, what we can do is that n-dimensional or whatever the non-linear kind of the structure we are having, that thing can be converted into the two-dimensional format in a proper way. Okay, with the help of the kernel trick. And this thing is not there with any other algorithm, friends, because SVM, if you see, the most complex kind of the data items or data set can be given to our SVM, and SVM fairly separates, okay, these kind of different non-linear kind of the models into some sort of linear models. Okay, for that particular purpose, we're having the kernel trick. That is the most significant part of our support vector machine. Okay, now as usual, same kind of the usage. Like, let me introduce how we are what exactly our case study in case of our SVM. Here a kind of medical domain we have taken, friends. As usual, we are importing the packages NumPy, Pandas, Matplotlib, Seaborn, all these things. And here one of the important aspect, some of the data sets already available in our sklearn package, friends. Okay, sklearn basically it's not only providing some kind of the functionalities, but also you can make use of some existing data sets also. Like long back, if you remember, we have seen this thing, friends, Seaborn. If you recollect, Seaborn data set, if I am typing, okay, hope you guys are seeing the screen. Yeah, okay, just you can refer, click on this, and it is showing some kind of the data set, which is a default data set. Click on this kind of GitHub, okay, whatever the model, and you can observe here whatever the data set provided by the Seaborn. Maybe attention, brain networks, car crashes, diamonds, exercise. Okay, all these kind of the data sets you can easily observe. Taxis data, planets, penguins. Even planets data we have worked, friends, if you remember and recollect, like Mercury and
Weight.
weight, yeah, diameter, mass. Okay, so we have taken the data, planets data from here only. Okay, likewise in this particular case also, friends, okay, while working with this sklearn, some default data sets would be there which are provided by our sklearn package. So as to access those kind of the data, we are having sklearn.data sets. From that we are loading the breast cancer data. Okay, so maybe the people who are having the background of healthcare, they can observe which are all the parameters, because here we are loading the data directly into CA. So here our CA is nothing but data frame. One data frame we are loading and we are getting this data. And there is some kind of properties with the data frame, friends. Maybe I can get columns information. I can get the index data. Okay, I may get some kind of the info, or else I may get some kind of the describe. Like that, I'm having some kind of the functions supported. Similarly, suppose that if you want to extract, okay, if you want to extract some kind of the feature names, what do you mean by feature, friends? Here, all your
No, the X file is independent.
X values, that's all. Okay, all your X values. That means whatever the that lump or whatever the piece they are testing, they can see the mean radius, mean texture, and all the perimeter. So all these are nothing but the feature names, friends. Okay, because these are all the features which are really helping so as to get the kind of whether it is malignant or benign. Okay, benign means no cancer, and malignant is a cancerous cell, so that they can segregate those kind of the aspects. And here we are having certain kind of the keys. What do you mean by dictionary, friends? Here, suppose I am having some that CA. From this, we could able to get the keys like data, target data, frame, target names, description of the data. Now, suppose that you are having some confusion, or you are not having any clarity about the appropriate data set, then one of the feature provided by our Jupyter notebook is the description of the data, friends. Okay, what it is saying? This is saying about breast cancer data set. Number of instances we have taken as 569. Number of attributes. What do you mean by attribute, friends? Attributes are nothing but columns. Okay, those particular 50-30 columns we are having. And information, radius, texture, perimeter, area, smoothness, like that it is giving some kind of the description. Okay, so and you know what do you mean by the summary statistics is generally in case of the description. Okay, if I'm talking about the our own way of df.info, df.describe, you can able to see the mean value, minimum, maximum, all these kind of things you can see. Here also we are getting the same kind of the things. Okay, and from this particular thing, the distribution we are giving 212 are relevant to the cancerous cells, and 357 are not the cancerous cells. So that is how you can refer. And the data set created by, because this data set is already there now, that's what it is giving some kind of the convention. And one more thing, friends, I strongly recommend you guys, just you can go and test this UCI machine learning repository. Okay, what I'm doing is here, let me take this opportunity of introducing that particular thing. UCI ML repository. Okay, so this machine learning repository is having some kind of data sets. Okay, you cannot you need not stick on to whatever the data we are working. Okay, but these are all the popular data sets which we can bank on. Okay, like Irish data set, and as well as the wine quality, heart disease. Okay, now we are talking about this one, breast cancer data. All these kind of the things are there. Student performance, generally student performance we have used, if you remember, in case of the Matplotlib and Seaburn. Can someone recollect, friends? What is the problem we have used there? So the World Bank is promoting their candidature, and there they are given some kind of the test, written test and retest, and whether their parents are having graduation or post graduation, whether is any impact is there. Such kind of the things we have seen basically. Okay, so you can make use of whatever the convention. And however, now we are using this cancer data set, and Irish also. Basically, this Irish is some kind of the flower data set, where this is giving some kind of the length and width of the kind of flowers, and based on those kind of the parameters we have to use. And I thought of giving this Irish for the KNN, but rather than taking the default data set, I thought of taking some classification data, and we want to apply some KNN. Okay, and I can share that particular code also, guys, where you can observe this Irish applicability. Okay, because these are all the default data sets which we may not use in the real-time scenarios. No? These are all for the learning purpose, for the demonstration, and all these kind of purpose only we are using. In your case, after joining a company and all, you need to work out, okay, whatever the data set is having with the kind of the data set only you are going to work out. Now, coming back to our discussion, I want to get the features, friends, now. What I can do, but there is a slight differentiation compared with the normal data set and as well as the predefined. Now, this time, what I'm doing is, in the data frame, I'm making use of, okay, some all my whatever the features I'm having as the data, and I'm having my columns name as separately feature names. I need not worry about which are all the labels and all. And if you remember, friends, long back, if you see the concept of the data frame, there you can specify your data and as well as the index values, or data and as well as the column values. Similarly, in case of this particular data frame, what we are doing is, along with the data, just we are mentioning the feature names. So whichever the features I am having, just I can make use of the nice specification of the data frame. Now, the first 5 records I am getting, so which are span over to 5 rows and as well as the 30 columns. However, I'm having the 30 columns. Now about the info, what exactly info is giving, guys? How many null values are there and what is the count and what is the data type? All those things you can get. Okay. So however, I'm having how many rows I'm having basically here from the observation of the data set. There we have seen earlier 569 friends. Okay, total number of instance at 569. From this particular info also we got that 569. All are not null only. You see, all the whatever the 30 columns I'm having, all those particular 30 columns are not null because this is a medical data. Medical data accuracy is very important, friends. Okay, there should not be any null values or we should not go with some kind of the scaling or whatever the aspects. Okay, now directly if you see the target names, malignant is 1 and benign is 0. Okay, not the cancerous cell, and this is the cancerous cell, that is the target name. Now up to this a slight modification is there compared with your a normal understanding of the data set. We are making use of the default data set so that we can directly make use of the features and as well as the target classes. So that's what we are doing, this kind of the convention. From this point of words, normal train test split. Okay, and x value is features and y value is target. Now we are sending this x and y, and now this time I'm taking the test size as 0.2, my random state as 101. I can completely take that as a optional also. Though you are not giving also, nothing is going to happen. Now if I am talking about this SVM, actually support vector machine is not a single algorithm, friends. We are having two algorithms: support vector classifier, support vector regression. Though support vector basically support the classification model, but I can make use of that thing for the regression. But however, the best methodology or best accuracy you can make use with the SVC only rather than the SVR. So just we are making use of this support vector classifier. Don't worry, friends. Support vector classifier is an algorithm which is provided by sklearn.svm. Now we are directly using that SVC and we are creating the model with the help of this classifier and fitting up the model with the help of X train and as well as the Y train, and then model prediction with the help of the X test. Finally, we are going to generate the Y prediction. Now metrics, as we are making use of our classification, they are again confusion matrix and as well as the classification report. Now what we are doing, friends, here confusion matrix between Y test and as well as the Y prediction. Now you can see here. Okay, so very surprising aspect. So just whatever the things I'm having, so very less, friends. False things are very less, whereas only 6 entries are fell in the category of the false, and even our model is properly observed these particular entries as 0 to 0. Okay, exactly, it could able to observe, and remaining and all you can able to see the maximum kind of thing. And now the classification report 92% and 96 and these kind of thing. And most importantly, of course this is fairly observable in case of the SVM, especially the data set is very powerful because that is a data set which we have picked up from medical domain. So obviously the accuracy should be more. And one more thing, friends, as we have discussed in the conceptual aspect of this particular support vector machine, we are having the kernel trick. Actually, we are having linear kernels, radial basis, sigmoid, like that. We are having kernel, and this particular C value, if I am talking about this particular C, just to observe here what exactly this documentation is. It is giving some classification. Okay, and now we are having certain parameters. Have you remember what do you mean by regularization, friends? We have seen some kind of the concept called regularization and as well as the penalization. That means to strengthen the concept of the regularization, okay, just we need to apply some kind of the penalty. Okay, regularization, penalization sense, which are all not really contributing, we need to penalize them, whatever the feature, so that just I am giving some kind of the value here instead of this particular C. Now I am trying to connect and I could able to see some kind of the more values. Okay, more negatives. Of course, 6 also got reduced, and but total 5 this time. Earlier we got 6, na? This time 5, and ultimately these positives has raised actually 36 to 39, and a little bit less friends here. Okay, 72 got down into 70, but I can fairly observe 95 and 96 kind of the accuracy and precision values. Now there is one more option called grid set CV, friends. Have you remember this topic we have discussed? This topic at a glance I will give. However, tomorrow again we are going to talk about this topic. Suppose we are having multiple parameters, friends. You don't know which one is really doing well, because I'm having linear, radial basis function, sigmoid. Like that, I'm having my C value as 0, 0.01. Like that, I'm changing the values. Now this particular grid set CV is one kind of the option which is available in the model selection. Out of all these kind of the parameters, it is going to give the best one, friends. It is going to give the best one. That means though I am having 3 or 4 different kinds of the methodologies, so as to come up with the best option out of my algorithm, but I am in a confusion because I cannot go brute force. I cannot spend that much time in verifying each and every methodology in case of the kernel and my C value, that is a regularization parameter. Simply what I can do is I can depute this grid set CV, and itself, okay, what it says is your SVC performs well if your C value is 1, and if you make use of the kernel as linear. Okay, you need not go for a C value at 0.01 or 0.1, and you can you need not go with kernel, kernel trick of RBF and sigmoid. Your SVC is better performed whenever you are using the linear and as well as your C value as 1. So straight away you can apply that particular model as linear, and if you change the C value as 1, you can get the best parameters. Okay, that is how you can observe the usage of the grid set CV. And not only in this case, friends, you can apply this particular grid set CV in any other kind of the algorithm, provided you need to have some multiple options. Like, you know, in case of the SVM, because we're having this linear, RBF, sigmoid, okay, like that we're having kernel tricks. But grid set CV's main significance is to select, okay, to suggest whatever the parameters, because here I am having 6 combinations, 3 in kernel and 3 in my regularization parameter. Total 9 combination would be there. Rather than checking all these 9 combinations in the brute force, I can bank on this grid set CV so that it can suggest me to come up with the kernel is linear and C value as 1. Okay, so that is what I want to share with you guys. And now, but you badly need the revision process, friends. So tomorrow, definitely I'm each and everyone I will ask, and I'll take the concern, like, you know, whatever the aspects we have covered, and especially I have mentioned. So can someone help me? Which are all the key takeaways, guys? Key takeaways. What is the first point we have started? Discussion of the confusion matrix. And thereafter we have discussed about accuracy, some kind of the recall, true positive, and false negative kind of the aspects. And then we have seen the KNN working model as a glance. And then we have introduced the case study of some kind of the classification or classifier, classifieds, actually classifieds data we are having. There we could able to see the KNN imposing on the corresponding data set. Now what we have observed, friends, there we have given KNN value as 1, KNN value as 5, and KNN value as 23. Randomly we have given and we can easily observe the difference between those kind of the performance. And fifth one, now we have seen the case study of support vector classifier, which is some kind of the cancer data, which is a default data set, okay, which is provided by sklearn dot. We are having some data sets, and we have imported some kind of the cancer data, whatever the data we are having. And there is a slight modification. Okay, so rather than directly segregating X and Y, we are having some features and as well as the target class. Based on that convention, we could able to see. Next, in a high level view, we come across with SVC and as well as grid set CV. Okay, so this grid set CV suggest, okay, which is the best parameter out of the kernels and as well as the regularization kind of aspects. And the support vector classifier is we have taken from support vector machine. From that we have taken the SVC. So this is how you can go through and verify the support vector machine and as well as the support vector classifier. Okay, anything else, guys? Venkat, Lakshmi,
One small question.
please.
In this, we have in using your coding here for the Y directly. We were using drop this thing. Correct. But when you're going with the imputation in the first one, we didn't do a drop actually. We were doing a code which, like, you know, it takes only with, you know, with a -1, with a 0 and all the stuff. You remember?
Yeah.
Why? What is the difference? Like, you know, we can't use drop there also?
You can use, no problem, because this is another method.
It's another method.
Another method. Because how many methods we have seen, friends? Can quickly reconnect? Quickly. First thing, initially we have used, if you remember, in case of the linear and multiple linear regression, we have used this concept actually. Like directly we could able to mention x1, x2, x3. That's all. That's all. In case of Y, just we can able to give the label directly. This is the one method. So this is the first method actually to separate the XY values. Second method, as our friend rightly said, just there I am taking my data frame and then I could able to specify colon and directly I'm using -1. And like that we are using the drop off the corresponding aspects. Okay, so some of the aspects we can drop. Okay, whereas this particular Y, the label value, and remaining things I'm making use of X kind of the things. This is one method. Now in this particular case, as I'm loading the default data, okay, there are certain conventions now already X and Y are properly managed, so that I can able to see the features directly and as well as target values also, so that I am using the convention. Okay, you can go with either of method frame, but I suggest this is the best method out of that. You need not worry about first one, because directly we are mentioning the values. And but the problem here, what is the problem here, guys? Just now we have seen support vector, the data set is containing 30 columns. I cannot give all the 30 columns. No? That's what simply you can drop that target and you can make use of the remaining thing. That's what we have used this convention here. Okay,
that looks really good. Dropping off is easy, like, you know, to remember also.
That's it. You remember also, you can easy. Yeah.
It's okay.
Any other guys? Any other doubts? Okay, but just I strongly recommend you come up with the preparation, guys. Okay, just to revise and recollect. Thank you.